Can this engine kill stern drives forever? That's a question the industry is asking. While stern drives rack up maintenance bills that'd make Ferrari owners blush, a different propulsion system has been perfecting itself. We're talking about an engine delivering over 500 horsepower, without a single outdrive, bellows, or gimbal bearing. But here's the twist. This isn't radical new technology, it's proven automotive engineering combined with a particular propulsion system making stern drive manufacturers nervous. The numbers backing this are wild. Let's be honest about something the marine industry doesn't want you thinking too hard about. Stern drives come with a dirty little secret that costs owners thousands. Every stern drive is essentially a maintenance time bomb with cast aluminium components that can't be made truly corrosion resistant, rubber bellows that degrade predictably, gimbal bearings that wear out, and anodes needing constant monitoring. Miss your maintenance window and you're looking at repair bills from $800 to $8,000. Here's the engineering reality. Stern drives put massive complexity partially submerged in water where physics works against you. Electrical currents literally carry metal molecules from your outdrive into the water through electrolysis. That's not a defect, that's just chemistry with dissimilar metals in saltwater. The industry says this is the cost of performance, but what if 90% of those underwater failure points could be eliminated entirely? The typical stern drive draws 30 to 36 inches of draft, meaning constant worry about hitting bottom, no shallow cove access, and a prop dangerously close to swimmers during water sports. Stern drives do offer interior space advantages and decent cruising fuel economy, but when you factor in maintenance complexity and shallow water limitations, they're a compromise we've accepted too long. We're diving into something mind-blowing. If you're finding this valuable, smash that subscribe button because we're exposing propulsion secrets dealers won't tell you. What's coming will change how you think about boat shopping. Hit share because your buddies need this before dropping 80 grand on another stern drive nightmare. Here's where things get interesting. The Indmar Raptor isn't some boutique marine engine cobbled from exotic parts. It's built on Ford's 6.2-litre 16-valve V8 SOHC Super Duty block, the same platform powering F-Series trucks with 250,000 plus miles. While marine engines get a finicky reputation, Indmar took America's most proven automotive power plant and re-engineered it for marine duty. The Raptor 440 delivers 440 horsepower on 89-octane mid-grade fuel. But the torque curve tells the real story. This engine delivers best-in-class torque and horsepower between 2500 and 3500 RPM, exactly where you need power for pulling skiers or pushing hulls onto plane. Most marine engines rev higher to hit their power band, burning more fuel and creating mechanical stress. The Raptor delivers usable power where it matters. The Raptor uses computer-controlled sequential firing multi-port EFI with wideband air fuel sensors and dual park plugs per cylinder. This real engineering delivers up to 20% better fuel economy versus comparable engines, meaning more water time and less fuel dock time. When the engine derives from a platform hauling work trucks hundreds of thousands of miles, these numbers make sense. The marine-specific oil pan and pickup tube optimize oil pickup at steep angles and high G-turns. If you're worried about oil starvation during tight water sports turns, this solves it. The pan controls oil movement, preventing catastrophic damage when the pickup sucks air instead of oil. These thoughtful modifications separate true marine engines from automotive conversions. Closed cooling is standard across the entire Raptor line, even the base 400. This maintains consistent temperatures, infuels fuel economy and performance, prevents crankcase condensation, and eliminates corrosion-destroying open-cooled engines. Winterization becomes dramatically simpler without complex water passage draining. Indmar backs this with a 5-year factory warranty administered directly through them with no third-party insurance, fully transferable to new owners. The overhead cam design with cast iron block and exhaust manifolds runs smoother and quieter than typical marine V8s. The high-stress cast iron manifolds and ultra-quiet stainless steel tubular catalyzed exhaust contain heat better, helping the catalyst perform more efficiently with emissions exceeding the required 4-star rating. Now let's talk about the boat putting this engineering to work differently than anything you've seen. The KYMA K7 measures 23 feet overall, extending to 25 feet 6 inches on trailer. It's got a 102-inch beam, 20.5-degree dead rise, and here's the number that matters, just 17.5 inches of draft under normal load. Remember stern drives pulling 30 to 36 inches, the KYMA operates in half the water depth. This works because KYMA mated the Indmar Raptor 44 or 575 to an American turbine SD231 jet pump, instead of a stern drive or V-drive. That American turbine unit features a 9-inch stainless steel impeller cast from 17.4 pH alloy. That's twice as strong as competitors. The self-cleaning impeller design flushes debris through rather than jamming, critical for shallow water with vegetation or rocks. Unlike traditional jets struggling with rooster tail wash, KYMA uses a single jet mounted downward to eliminate spray problems. But KYMA didn't just bolt a jet pump on and quit. They integrated Seakeeper Ride active stability control using rapid actuation rotary blades, making 100 adjustments per second. KYMA worked with Seakeeper to enable manual independent deployment of actuators to actually shape the wake for wakesurfing and wakeboarding. With 300 pounds of onboard ballast engaged and Seakeeper Ride deployed, the KYMA produces wakesurfing waves genuinely comparable to dedicated V-drive surf boats, something jets historically struggled to achieve. The jet drive handling is dramatically different from stern drives, especially at low speeds and reverse. Stern drive prop torques pulls boats directionally, making maneuvering a learned skill. The KYMA features zero turn capability, letting you spin on axis, making docking easier than any prop boat. Dometic Optimus digital steering gives precise control that feels telepathic. Here's the practical ownership angle. The jet eliminates prop-related injuries during water sports since there's no spinning blade near swimmers or fallen riders. You can't damage the drive by grounding because nothing hangs below the hull. Shallow draft means accessing coves, sandbars, and beaches prop boats only dream about. For maintenance, you've eliminated bellows, gimbal bearings, lower unit oil changes, and constant corrosion battles. The KYMA K7 Supercharged uses a 6.2-litre Roush supercharged V8, producing 510 horsepower and 575 pound-feet of torque. That Roush supercharger isn't bolt-on aftermarket. It's integrated with full factory warranty. The supercharged version requires premium 91 to 93 octane fuel, preferably 91E0, using fully synthetic 15W50 oil for the increased heat and stress. Operating in the same 2500 to 3500 RPM range, you've got massively more torque available throughout. This makes the KYMA genuinely competitive with the fastest stern drive boats without maintenance complexity or shallow water limitations. The Indmar Raptor engines aren't exclusive to KYMA. They're in numerous wake boats from Tig, Mumba, and others, typically with traditional V-drive or prop setups. These boats use the same engine but push props instead of jets, creating interesting comparisons since you can isolate the propulsion system as the primary variable. Traditional V-drive wake boats deliver excellent wakes using similar ballast and hull design principles, with plenty of torque for quick planing and consistent water sport speeds, but those V-drive boats still deal with props 3 feet underwater, making shallow water a constant concern. They require careful navigation with prop location awareness relative to swimmers. Fuel economy can be excellent thanks to Raptor efficiency, but you're winterizing a raw water system with its complexity. While V-drives are less maintenance intensive than stern drives, you've still got shaft seals, packing glands, and underwater running gear to service. The KYMA trades some wakeboat versatility for specialized capability in specific areas. Shallow draft opens cruising destinations prop boats can't reach. The jet means worry-free operation around swimmers with zero prop danger. Maintenance is dramatically simplified without underwater driveline components. But you're limited to the KYMA hull design rather than dozens of wakeboat models across manufacturers. It's a different philosophy, targeting boaters valuing shallow water capability, low maintenance, and water sports performance. If this is making you rethink boat propulsion, subscribe now. We dig into technical details and industry secrets manufacturers hide. Hit that like button to help more people find this before making expensive mistakes. Let's talk money. Traditional stern drive maintenance runs $800 annually if diligent, scaling to thousands when things fail. Bellows need replacement every 2 to 4 years according to Volvo Penta recommendations, with most manufacturers agreeing that 5-year-old bellows are living on borrowed time. The parts themselves run $125 to $150, but labor is the killer at 3 to 5 hours per replacement, and you've got 3 different bellows per drive: exhaust, U-joint, and shift cable. When one fails and lets water in, it doesn't just sink your boat, it ruins gimbal bearings, U-joints, and corrodes the input shaft seal, turning an $800 job into $4,000 overnight. Zincs need constant monitoring, as you're fighting corrosion constantly. Over 10 to 15 years, stern drive owners easily spend $15,000 to $25,000 on outdrive maintenance beyond basic engine service, before pricing a complete outdrive replacement at $8,000 to $12,000. Jet drive maintenance is completely different. You're changing impeller wear rings based on hours, but no bellows, gimbal bearings, or corrosion-prone casings in the water. American turbine SD-231 parts cost significantly less than stern drive components. Engine service remains identical whether running prop or jet, so the differential is entirely propulsion system related, and jets win long-term by a significant margin. Stern drive manufacturers haven't sat idle. Mercury, Volvo Penta, and others invested heavily in corrosion-resistant materials, improved seals, and efficient lower units. Modern stern drives are significantly better than 10 years ago, but they still fight the same physics. Complex mechanical components partially submerged in corrosive environments. That's a battle you improve, but never fully win. Some wakeboat manufacturers now offer outboard options with twins or triples on the transom, solving corrosion and maintenance issues but losing clean transoms for water sports platforms, affecting weight distribution and still dealing with underwater props. The jet drive approach KYMA pioneers for water sports is genuinely different from established manufacturers. Most major wakeboat brands remain committed to V-drive props because that's what they've optimized hulls around for decades. Switching to jet propulsion requires completely rethinking hull design, weight distribution, and wake formation. Incrementally improving existing designs is easier than fundamentally reimagining the platform, creating opportunities for new entrants like KYMA to target specific customer needs traditional designs serve poorly. Let me be the voice of reason. If you primarily boat in deep water without shallow areas, sandbars, or vegetation, shallow draft becomes less compelling. If you want the absolute biggest wake surfing waves possible and don't care about draft limitations, some dedicated V-drive surf boats with massive displacement still hold an edge. And if shopping used boats, the stern drive market is massive, with thousands of options at every price point, while jet-powered wake boats remain a niche with limited selection. The KYMA specifically carries a base price around $145,000 to $175,000 depending on configuration, positioning it as a premium offering in the 23-foot category. That pricing puts it alongside fully loaded V-drive wake boats from established manufacturers like Teague, Mumba, and Axis. For that money, you're getting Boating Magazine's tested top speed of 45 to 47 miles per hour, which genuinely outperforms most V-drive wake boats, but you're also accepting that this is a relatively new platform from a new manufacturer without decades of real-world reliability data to examine. Here's what you should actually evaluate before writing a check. First, the Indmar Raptor engine itself has proven reliability across numerous boat brands for years, so engine concerns are minimal. The American turbine SD231 jet pump has been used in riverboats and harsh-duty applications for decades, so that technology is well established and field-proven, but the specific integration of these components in the KYMA hull, the Seakeeper ride system programming for wake shaping, and the overall boat systems are first-generation products. That means early adopters should expect some refinement as the platform matures. Indmar backs the engine with their 5-year factory warranty, but verify exactly what's covered on the jet drive and boat components. The dealer and service network is another practical consideration requiring homework before purchase. Indmar has over 1,800 service locations worldwide, so engine service is readily available. But finding technicians familiar with the specific KYMA systems, the Seakeeper ride programming, and the American turbine jet pump maintenance may be more challenging depending on your location. This is improving as more boats enter service and technicians gain experience. But it's worth considering if you're in a remote area or far from major boating centers. Call around to local marine service shops before buying and confirm they're willing and able to work on the boat. Make sure you've got qualified service available before you buy any specialized boat, and that advice applies whether you're looking at KYMA, traditional wake boats, or performance stern drives. Now, I know many of you are outboard enthusiasts wondering why any of this matters. Here's why you should care. The marine industry has been dominated by a few propulsion paradigms for decades. Outboards for smaller boats and fishing, stern drives for mid-size performance boats, and inboards for larger vessels and water sports. That status quo has meant limited innovation, because manufacturers focused on incremental improvements rather than rethinking fundamental assumptions. The emergence of viable jet drive alternatives signals the industry is finally being forced to innovate meaningfully. The outboard market has already undergone massive evolution, with larger, more powerful engines, digital controls, and improved efficiency, but propeller limitations remain. Hitting bottom in shallow water, prop danger around swimmers, and relatively complex lower units. If jet propulsion proves itself in the demanding water sports market, where performance and reliability are absolutely critical, that technology will inevitably migrate into other applications. Imagine an outboard-class jet drive offering the simplicity and power of modern outboards with shallow water capability and the safety of jets. That's probably where this heads, and the KYMA K7 helps prove the technology works. While this engine won't kill stern drives completely, the Indmar Raptor paired with jet propulsion eliminates the rational justification for choosing stern drives in water sports and shallow water markets. If you can get equivalent performance, dramatically lower maintenance, genuine shallow water capability, and improved safety in one package, why voluntarily sign up for bellow replacements and corrosion battles? Subscribe to this channel for more propulsion system realities that dealers won't tell you, and watch my video on propeller physics to understand why props have inherent limitations.